Of looking at binomial expansion. So what I want you to do is pause the podcast for a little bit, and I want you to see what patterns you notice in this. And then once you take a look at it, then let's have you start again. So hopefully you noticed we have to the first power. Some of you may have noticed these coefficients, 1, 2, 1. So it corresponds to 1, 2, 1. You may have noticed this next one. We got 1, 3, 3, 1. So 1, 3, 3, 1. You may notice here we got 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Others of you might have noticed, well, how do I get the next row? Well, we add above. So 1 plus 5 is 6. 5 plus 10 is 15. 10 and 10 is 20. 10 and 5 is 15. 5 and 1 is 6. And then 1 on the end. So our next row would be 1, 7, 21, 35, 35, 21, 7, and 1. So here's the deal. What we're going to do is we're going to try and see how to get expand something like this. So some of you probably noticed it went 3, 2, 1, and then 0. And going with the other one, we had 0, 1, 2, 3. So our powers, the first one starts high and goes low, and then it starts low and goes high. So we're going to look and see how we can use this, what's called Pascal's triangle, to expand some stuff. So the first one we're going to look at is x plus 3 to the 4th. So if we take a look at our pattern, we're going to use the row that has that power in it. So our 4th row would be right here. Highlight this row for you. And then we can add these on. So we're going to start with the 1. Then we have our x term to the highest power. That second one to the lowest, to the 0. Plus our next term, so we have 4. Then we'd have x to the 3rd. 3 to the 1st. Plus 6, x squared, times 3 to the 2nd, plus 4 times x to the 1st, 3 to the 3rd, plus 1, x to the 0, 3 to the 4th. And now we can just simplify this further. Well, 1x to the 4th, well, that's just x to the 4th. Plus, when we take this, we can combine our numbers. So 4 times 3. So that would be 12x cubed. Plus, let's see, this one, we'd have 6 times 9. So 9, well, that'd be, 54. X squared. Plus, we have 4 times 3 cubed. Well, let's see, that's 27 times 4. 28, carry the 2. So we have 108, x to the 1st. And x to the 0, that's just 1. So we have 3 to the 4th, which is 81. So let's take a look at the next one here. We're going to take a look at one with subtraction. So 2x minus y to the 5th. So we're going to have to use that 5th row. So I'm just going to copy this 5th row so I don't need to keep going up there. Well, that didn't copy the 5th row. Apparently, I can't copy that again. Let me try going up here. 5th row. All right, so there's our 5th row. So we're going to start with 1. And then we'd have 2x to the 5th. But notice it's negative y. So negative y to the 0. Plus we got the 5. 2x to the 4th. Negative y to the 0. Plus 10. 2x to the 3rd. Negative y squared. And let's back up here. Our powers have to add up to 5, so that must be 1. Plus 10 times 2x squared negative y to the third plus 5 2x to the first negative y to the fourth plus 1 2x to the 0 negative y to the fifth. So now we just have to simplify this down, and that's probably the trickiest part. So if we take a look at this one, we have to raise both of these to the power. So anything to the 0 power is 1. So 1 times 2 to the fifth would be 32x to the fifth. Plus, let's see, 5 times 2 to the fourth. Well, 2 to the fourth, so that's 16 times 5, so that's 80. But we have that times negative y, so that's not going to be a plus right there, because negative y to the first is minus. So it's going to be minus 80x to the fourth y. Let's see this next one. We distribute that. 2 to the third is 8 times 10. And we have a negative y squared, so that makes a positive. So that's got to be plus 80x cubed y squared. And then this next one, let's see, 2 squared is 4. So we have 40, but it's negative y cubed, so the negative stays. So negative 40x squared y cubed. Let's see this next one to the first, so that's just 5 times 2. Negative y to the fourth is a positive. So plus 10x y to the fourth. Anything to the 0 power is 1, so we just have minus y to the fifth. So expanding is not too bad, but sometimes we might just want to find a certain term. So let's take a look at if we were asked to find the x cubed term in 4x minus 1 to the 7th. Well, I know that x cubed term is going to have 4x cubed. So if it's to the 7th power, it's got to be negative 1 to the 4th. We're going to look at the 7th row here, because here's our 7. And let's see, to get that get that third term. So if we were to start this out, this would be x to the 7th, x to the 6th, x to the 5th, x to the 4th, x to the 3rd. So we're going to have a 35 before here. So it would be whatever 35 times 4 cubed, x cubed, and negative 1 to the 4th is just negative 1. So I'll leave that to you. You could go and type that in and see what your coefficient is. So let's say we had to find the x to the 5th term in x plus 3y to the 5th. So we know that this is going to be x to the 5th times 3y to the 0. So x to the 5th term, we're going to look at the 5th row. Well, if we are using this row right here, this is going to just start 1x to the 5th. So that coefficient in front is just the 1. So our x to the 5th term is just 1x to the 5th. And one last one here. Let's say we have in 2x plus 1 to the n, the coefficient of the x cubed term is 80. And you have to find n. Well, let's see, we're looking at the x cubed term. So we know that this is going to be 2x cubed times, well, whatever n is, it's going to be n minus 3. So we don't know that value out in front. So maybe I'll just put a y. There's some number, and we know this equals 80. Well, we know 1 to any power is 1, so technically we don't need to worry about this. So this is really y times 2 to the 3rd times x to the 3rd equals 80. So let's see. This is 8yx cubed equals 80. And we're just concerned about the coefficient part. So what would y need to be? Y would need to be 10. So y is 10. So we know that number out in front is 10. So which triangle, which row has a 10 in it? Well, that's one with the fifth row. So that means our power, n, would have to be 5.